Hey guys, welcome back to our channel. Today let's talk about RFID and how we can use it and also how to interface it with an Arduino. And in case you like our content, do like and share it with people who might find this useful. Also do consider subscribing and hitting the bell icon to not miss out on any further updates. RFID is an acronym for Radio Frequency Identification and refers to a technology where digital data encoded in RFID tags or smart labels are captured by a reader via radio waves. RFID is similar to barcoding, but the most notable advantage over systems that use barcoding asset tracking software is that RFID tag data can be read outside the line of sight, whereas barcodes must be aligned with an optical scanner. In this RFID system, the RFID reader continuously sends radio waves of a particular frequency. If the object on which the RFID tag is attached is within the range of this radio waves, then it sends a feedback uh, back to the RFID reader, and based on this feedback, the RFID reader identifies the object. At a simple level, RFID systems consist of three components: an RFID tag or smart label, an RFID reader, and an antenna. RFID tags contain an integrated circuit and an antenna, which are used to transmit data to the RFID reader. The reader then converts the radio waves to more usable form of data. The information collected from the tags is then transferred through a communication interface to a host computer system, where the data can be stored in a database and analyzed at a later time. Now, there are three different types of RFID tags that are commercially available: passive tags, active tags, and semi-passive tags. Passive tags do not have any power supply. They used to get their power from the incoming radio waves from the readers, while active tags have a power source for their internal circuitries, and for sending the response to the reader also it uses its own power supply. In the case of semi-passive tags, they have a power supply for internal circuitries, but for sending the response it relies on the radio waves received from the reader. RFID system is mainly operated in three frequency bands. LF, for the low frequency band, operates at a frequency of 125 kHz to 134 kHz and has a range of around 10 centimeters. HF, or high frequency band, operates at a frequency of 13.5 MHz and has a range of around 1 meter. UHF, or the ultra high frequency band, operates at a frequency of 860 MHz to 960 MHz and has a range of around 10 to 15 meters. These frequencies, however, for each band varies from country to country. The RC522 is a 13.56 MHz RFID module that is based on the MFRC 522 controller. It is commonly used in attendance systems and other person or object identification applications. The RC522 has an operating voltage between 2.5 volts and 3.3 volts and is hence normally powered by 3.3 volts. Should be also used with 3.3 volt communication lines. The module supports SPI, I2C and UART communications, but out of these, SPI is often used because it is the fastest and has a highest data rate of 10 Mbps. Since in application most of the time the reader module will be waiting for the tag to come into proximity, the reader can be put into a power down mode to save power in case of battery operated application. This can be achieved by using the IRQ pin on the module. The minimum current consumed by the module during power down mode will be around 10 microamps only. Here is the circuit diagram, and the VCC supplies power to the module that can be connected to a 3.3 volt output from your Arduino. RST is an input for power down and reset. When low, the hard power down is enabled, turning off all internal circuit sinks, including the oscillator and the input pins that are disconnected from the outside world. On the rising edge, the module is reset. GND is the ground pin. IRQ is an interrupt pin that can alert the microcontroller when RFID tags come into the vicinity. The MISO pin acts as a master in slave out when the SPI interface is enabled. MOSI, or the master out slave in, is an SPI input to the RC522 module. SCK, or the serial clock, accepts clock pulses provided by the SPI bus master, that is the Arduino. SS pin acts as signal input when the SPI interface is enabled. This pin is usually marked by encasing the pin in a square so that it can be used as a reference for identifying the other pins. Once you have everything hooked up, we can start writing the sketch. To do this, download the MFRC522 library first, then open example submenu and select MFRC522 and the dump info example sketch. In the beginning of the sketch, make sure the RST pin is correctly initialized. In our case, we're using digital 5 digital pin 5, so change it to 5. Now upload the sketch and open the serial monitor. As soon as you bring the tag closer to the module, you'll probably get something like the following. Do not remove the tag until all the information is displayed. It just tells you if it managed to read the tag and it displays some information about it. This can be very useful while trying out any new tag. The 1K memory of the tag is organized in 16 sectors, 0 to 15. Each sector is further divided into 4 blocks, 0 to 3, and each block can store 16 bytes of data, so collectively 1K memory. Block 0 of sector 0 is known as the manufacturer block or the manufacturer data that contains the IC manufacturer data and the unique identifier. Now that we've learned how to identify a given RFID tag, let's try and see if we can implement a system to utilize the names of these RFID tags to, say, open a door or any kind of security system. Now using the same code, we initialize content and letter to obtain the ID of each tag that is being detected. To obtain the UID, we need to go to the 0th bit and concatenate the characters in those bits. Now that I've identified the UID of the tag, we can proceed to use this as a card that the system knows and display a message, and if not, display an error message. In each of these if statements, we can connect a servo motor or any kind of mechanism to secure a system. Now go ahead and upload this to your Arduino, and when the RFID tag is brought near this reader, you can see the appropriate output. Thank you guys for watching, and if you liked what you saw, do click on the like button and share it with anyone who might find this useful, and do check out our other videos as well.